All right, we are going to go over our do now. Let's see here. We were asked to graph the linear equation y equals -3x plus 4. What is our m? Go ahead.
-3.
-3, perfect. Jonathan, what's our b?
4.
Great. Can I have a volunteer come and graph this line? Kim, come on up. We have a slope of -3 and a b or y-intercept of 4.
Wait, like that here?
Nope, switch them. So our b is 4. So what's the point that we know? 0, comma
4.
Perfect. So that's our point. And then our slope is -3. So how far down do we go?
3.
How far down? 3. And how far to the right?
1.
Perfect. There you go.
See like that is?
Looks great. Connect those dots. Perfect. There we go. Great job, Kim. Thank you. Our second line, we've got y is equal to 3/4 x minus 2. What is our slope? What's our slope? 3/4. And what is our b? Go ahead. Okay, thank you. -2. So we've got a b of -2 and a slope of 3/4. Someone else please come graph this line for me. Someone come graph this line. You got it. Jonathan, come on. No? All right, Rodrigo, come on. What's the point we know?
3/4.
B, we know
Oh, -2.
B. -2. Perfect.
So I put that one here.
0, comma, -2.
Right here.
Yep. How far up do we go?
3.
Yep. And how far to the right? 1, 2, 3. How far to the right?
4.
Okay. So 1, 2, 3, 4. And then from that point, do it once more. Go up 3. 1, 2, 3. And over 4. 1, 2, 3, 4. Connect those dots. Nope. Straight line.
Oh, oops.
There you go. Awesome. All right, guys. Page 3, when you are ready. These are the lines we needed to have. They look good. Thank you, my volunteers, for coming up. All right, on your IA, and a little bit before, we were talking about scatter plots. We briefly talked about them. They're just going to be a whole bunch of points graphed on a coordinate plane. We have a couple new vocab words attached to scatter plots. Our first one is bivariant. Bi is a prefix that means 2, so this word means that it has 2 variables. So we're looking at things that have 2 variables, like an x and a y. We've got the word data or data. Data is a set of measurements or values. Our third vocab word is scatterplot. It is a graph where 2 variables are plotted along 2 axes to see if there is a pattern or correlation between them. Correlation is a connection between variables. You have to ask yourself, is the increase of one variable related to the increase or decrease in other variables? Please stop. And finally, observation, an ordered pair of the values of 2 variables. All right. Instead of an I do, we've got a class activity. I need someone who is willing to be my note taker. Let me get a volunteer. How about Julissa? Come on up. You're going to be my note taker. So Julissa, I'm going to call on a person. You're going to write down their name. I'm going to take their height in inches and then their height in reach. So and copy that down. And everyone else, copy that down as well. There you go. All right. I want someone to come up here to get measured. Alan, come on up. All right, so Alan, first you're going to stand here so I can get your height. Alan, you are 29, so 69 inches for Alan. All right, Alan, now stand in the middle with your arms out. You want to be touching this one. Perfect. And he's got a reach of 65. So everyone should be marking down Alan R, height of 69 inches, reach of 65. Let me get one more person. Rodrigo, come on up. Jonathan, you'll be next. All right, so let's see. How tall are you? We've got 25 inches for Rodrigo. Step back. All right, so stand in the middle, arms apart. You want to be touching this ruler with your middle finger. Tip your middle finger all the way out. Awesome, also 65 inches. All right, so Rodrigo was 65 inches. Oh, sorry, it should be 65. I'm sorry. 65 inches and 65 inches. Jonathan, come on up. Careful. Jonathan, you are 22, same as Kevin. Oh, sorry, 62. 62, yes. Okay, arms out. You want to touch this one, so flat. There you go. All right, and you are right here, 60 inches for his reach. Can we get a girl volunteer? Come on up, Alexa. All right, let's see how tall Alexa is. You are 64. And then your reach. Awesome. Perfect. 61 inches for Alexa's reach. Another girl. Alejandra, come on up. All right, Alejandra. Out your ponytail. You're 23, or so 63. All right. So lower your arms to their shoulder. Perfect. All right, that looks to be 62 for Alejandra. All right, someone else? See here, need another volunteer. Amy, come on up. Kaylin, you'll be next. Everyone should be taking these notes, filling in this. All right, let's see here. Looks like you're same as Bernice and Jessica. We've got 62. No, 61. All right, reach. Down a little. And 60 inches for Amy's reach. How many more? All right, Kaylin, come on up. All right, Kaylin, you are as tall as Isaiah. We've got 68, K-I-L-Y-N. 68 for Kaylin. And 64 is her reach. 68 and 64. Let's get a boy. Ivan, come on up. All right. Let's see. Ivan, you are 26. So 66 for Ivan. And your reach is 65 for Ivan. Thank you, Ivan. All right, we got 4 more spots. I need 4 more volunteers. Let's see here. Who haven't I seen? Sandra? Yes, please. Come on up. Let's see how tall Sandra is. So right here for me. Oh, you're 19, just like Emily and Noelle. So 59. Right? Shoulder. Perfect. And 59 for her reach. Thank you. David, come on up. Come on. Make sure you're taking all of these notes. You should have all of this table filled out. Jalissa's taking great notes for us. Oh, just like Ivan. 66 for David. Let's see your reach. So, the tip of your middle finger right here. Thank you. And we've got 64 for David is his reach. Thank you, David. Kim, can you come up? Can I measure you, please? And then Alan G, you're going to be next. Alan G, next. All right, lovely Kim. Let's see here. You are as tall as Valeria and Alejandra. So 63 for Kim. So arms out, shoulder length or shoulder height. So and all the way straight. That looks good. 62 for Kim's reach. And finally, Alan G. All right. Oh, you're as tall as Alan R. Oh, Alan squared. All right, so 69 for Alan G. Arms shoulder length or shoulder height. And we've got 67 for his reach.
Damn, that's the longest week.
Yeah, in this class. Thank you, Julissa. Go ahead and sit down for me. All right, make sure you have all of those data points in your table. I need all voices to be off. I need all eyes on me, including Jonathan. All right, now we're going to take those data points and plot them on the next page. To do that, our first step is to name this graph. So when we're talking about graphs and scatter plots, we need to name them with the variables that we're talking about. In this case, we are comparing, so we're going to say comparing miles, because that's this advisory, height, and reach. So that's the name of our graph. We need to determine what our x values and our y values are going to be. So we need to choose between height and reach. Jonathan?
Y is height.
Other way. Y is reach, and x is going to be our height. What unit were we talking about?
Inches.
Inches. Thank you, Diego. So height goes on the bottom, reach is on the side, and we are talking about inches. And then there's still one more thing we need before we can plot these points. What are we missing? Someone look at this and tell me what we're missing.
Numbers.
Numbers, perfect. I need everyone to put their distractions away. So, our smallest person was Sandra at 59 inches. So I think we're going to start our graph at 55. And we're going to go over by 1. So 55, 56, 7, 8, 9, and 60. 61, 2, 3, 4, 65 is right here. 66, 7, 8, 9, 70 is here. And 71, 2, 3, 4, 75. And we're going to do the same thing for the y values because I think, again, our smallest y value is not on anything under 55. So 55, 6, 7, 8, 9, 60. 61, 2, 3, 4, 65. 66, 7, 8, 9, 70. 71, 2, 3, 4, 75. So you should have, each one starts at 55. We're going up by ones. So you should have 60, 65, 70, and 75. Seeing a lot of people working hard on their graphs, looking great. All right, now we need to plot these points. So, I need a volunteer to read me off the points slowly as I plot them for and everyone else is going to plot them as well. So, volunteer to read me those points. Kaylin, go ahead. You're going to read us the points really slowly. So, what's our first data point? For the height, and then the reach. So, our first person's height and reach. 69, comma, 65. So we're going over to 69 and up to 65. So everyone graph that first point. 69, 65. Kaylin, what's our next point? 65, 65. So over to 65, up to 65. Next. 62 and 60. So over to 62, up to 60. Let's pause briefly so everyone can get down all of those points. All right, what is our next data point, Kim? I mean, not Kim, Kaylin, sorry.
64 and 61.
64, 61. Next. 63 and 62. 62 and 60. Awesome, we already have a point there too. So we've got 62, 60. 63, 62, and 64, 61. Those are the points that we've just graphed. Everyone write those down. All right, let's get some more points, Kaylin.
68 and 64.
68, 64. 66, 65, 59, 59. All right, so 59, 59, 66, 65, and 68, 64. Thank you, everyone, for plotting these points down. Kaylin, let's keep going. 66 and 64. 63 and 62. 69, 67. Awesome. All right, so the name of this graph is comparing height and reach. Our height is our x value. Our reach is our y value. Kaylin helped me to get all those points plotted. And now we need to ask ourselves one question. Do you notice a pattern in the scatter plot? In other words, does there appear to be a correlation between height and reach? So does it look like as the higher the height, the higher the reach? Yes or no? Raise your hand if you think yes, there is a correlation. Raise your hand. Got it. 1, 2, 3, 4, 5. Awesome. Raise your hand if you think no, there's not a correlation. I'll redo the vote. Okay, so raise your hand if yes, you think that as a person is, or if a person is taller, their reach is wider. Raise your hand. 1, 2, 3, 4, 5. Awesome. This looks like more than half the class. Raise your hand if you think no. If you're short, you're going to have a really high reach or a really wide one. Awesome. So this is correct. If we draw a line through these points, we can see that they're pretty much following this line. As our height goes up, so does our reach. And this is true. This is a true statement. The taller you are, the wider your reach is. And for most people, or for special people, their height and their reach are the same. So I think we had one person whose height and reach was the same, and it was Sandra. So Sandra is perfect. Her reach is the same as how tall she is, and that's great. So does there appear to be a correlation? Well, we voted and we said yes, there is. The taller you are, the wider your reach. The taller you are, the wider your reach. All right, I'm going to walk around, make sure everyone's taking these notes. Good job, guys. When you have all of those notes written down, we've got the whole scatter plot done. Turn to the next page. All right, we're on the we view, so I'm going to need some help from everyone to get this done. First off, a bivariate data set consists of observations on two variables. Remember, that was that first vocab word we saw. We're looking at things with two variables, an x and a y. For example, you might collect data on 13 different car models. Each observation in the data set would consist of an x and y pair, with x being the weight and y being the fuel efficiency, or miles per gallon. Below is the table that shows the weight and fuel efficiency for 13 car models with automatic transmission manufactured in 2009. In the table, the observation corresponding to Model 1 is 3,200, 23. What is the fuel efficiency of the car? What is the weight of the car? So which of those numbers corresponds to fuel efficiency? Is it 3,200 or is it 23? Someone, yeah. 23, perfect. Looking at the table, 23 is a fuel efficiency. So we're going to say 23 is the fuel efficiency. So what does that make for 3,200? Yep, the weight. On your exit ticket, you're going to see a question like this where it tells you an ordered pair. You're just going to have to tell me which one's what. Turn to the next page when you have that written down. All right, page 6. This is a very dizzying graph. So instead of graphing all 12, we're going to try 5 data points. All right? So, Amy, can you turn back to the previous page and give me one data point that we can plot besides 32 or 3,223? Give me another one. So 2,550, so that's going to be the 1 over from 2,515, so go up to 15. Oh, 28, sorry. Let's go up to 28 instead. All right. Make that dot kind of big. Doesn't have to be perfectly perfect for this one because it's a very difficult table to do. All right, give me another one, Amy. All right, so 4,015 and 19. It's going to be right about here. Again, you can make that dot kind of big. One more, Amy. And 20. All right, so 3,720. So 3,700, comma 20. And then one more. Maybe one in the 5,000 range. All right, 5,250 and 12. So we've got these 5 points that we've done on this graph. If we did all 12, it would probably give us a better picture, but this one's just very hard to plot on. Do we notice a pattern in the scatter plot? So does it look like there's a correlation between the heavier the car and the fuel efficiency? Raise your hand if you think yes, there is a correlation. Got 1, 2, 3, 4. All right, raise your hand, 5-ish. Okay, raise your hand if you think no, there's no correlation. All right, we're gonna vote again, guys. I need all people participating. Raise your hand if you think yes, there is a correlation. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 12, 13. Awesome. Raise your hand if you think no, doesn't look like it. Got 1, 2, 3, 4. Awesome. Well, if we drew a line like this, these dots do tend to follow that line. The heavier the car, the less fuel efficiency it has. So yes, there is a correlation. Thank you to my students who voted yes on that. So yes, it implies that the heavier the car, the more fuel efficient this car is going to be, or the less fuel efficient? The more fuel efficient or less fuel efficient it will be? Less. Thank you. And this should make sense. The heavier a car is, the harder the engine has to work to get it going, and the more fuel it burns doing that. So the heavier the car, the harder the engine has to work, and the less fuel efficient it will be. We have one more question on the we do, so go ahead and turn to it if you've got all this information down. Jonathan, will you please read this first paragraph for us?
The pattern in the scatterplot indicates that the value of one variable tends to vary in a predictable way as the values of the other variable change. This is called a statistical relationship.
Awesome.
And the fuel efficiency and car weight example, fuel efficiency tended to decrease as the car weight.
Perfect. So we've got this new vocab word, statistical relationship, and it's just saying that as one thing goes, or as one thing happens, we should see a relationship in the other ones. Either they're all going to increase or they're all going to decrease. I need someone else to read this next paragraph for me. Someone else, go ahead.
This is useful information, but be careful not to jump to the conclusion that increasing the weight of a car causes the fuel efficiency to go down. There may be some other explanations for this. For example, heavier cars may also have bigger engines, and bigger engines may be less efficient. You cannot conclude that changes to one variable cause changes in the other variable just because there's a statistic relationship with that.
Perfect. So what this is saying is pretty much you can't assume. You can't really assume anything from a scatter plot just because there is a correlation. And when you get into statistics and things like that, there's a phrase that says correlation does not link causality, which means that just because some things are correlated to each other, it doesn't cause that thing to be true or cause that thing to happen. In this case is a great case in point. So data was collected on shoe size, which is our X value, and Y is our score on a reading ability test. For 29 elementary students, the scatter plot of these data is shown below. Does there appear to be a statistical relationship between shoe size and the score on the reading test? So looking at this, if we draw a line, do these points kind of follow that line? I'm seeing some head nods. Yeah, it does. And if it does, then that means that yes, there does seem to be a relationship between shoe size and reading ability. But does that really make sense? Like the bigger your feet, the better you're going to read? Like that doesn't make any sense. So can someone please tell me why, although there is a statistical relationship, why it might not be a good assumption to make that the bigger your foot is, the better you are at reading? Can someone throw me out some ideas? All right. Everyone's being kind of shy. Let's turn and talk to our neighbor and for 30 seconds and discuss some reasons why the bigger your shoe size, the better you are at reading could be. Turn and talk to your neighbor. 30 seconds. 30 seconds. 15 more seconds. Talk to your neighbor. Why is it that the bigger your shoe, the better you are at reading? 10 more seconds. All right, come back to me. Diego, why is it not a reasonable explanation that the bigger your shoe size is, the better you are at reading? Age, perfect, Diego, that's exactly right. So age can be one factor. We're not looking at people who are all 7 years old. We're not looking at every 8th grader. We're looking at an elementary school. So these ones could be 1st graders, whereas these ones could be 8th graders. Well, we're in elementary. So what this means is that the older you are, the bigger your feet are going to be, but also the more practice that you will have had reading, right? So it makes sense that 8th graders would read at a higher level than 1st graders. So age, great job. So the bigger your shoe size, the older you are, I guess. And then the older you are, the longer you've been reading, So that will explain why we would have students with bigger shoes having bigger math scores or reading scores. That concludes our video section of this packet. So what we are going to do now is spend the next 10 minutes on the YouTube. We're then going to come back together, discuss what we did, and then we've got time for the exit ticket. Great work today, guys. If you have any questions, let me know. Otherwise, let's work on our own. Voices at a level 0. And work for 10 minutes. You got this.